Hello and welcome to another Big Astronomy Live event. Today we are featuring the Cerro Tololo Inter-American Observatory, and Juan Seguel is here to speak about the telescopes on Tololo and all the fantastic science that they do. Thank you for being here with us today, Juan. Juan is the Education and Engagement Specialist for NSF's NOIRLab, which runs all sorts of things, including the National Science Foundation funded telescopes in Chile. This program is a part of the Big Astronomy program, which is another National Science Foundation funded project. It includes a planetarium show that was created in both English and Spanish about these telescopes in Chile, but more importantly about the many diverse people and backgrounds and skills it takes to make the big telescopes work and to enable discoveries. You can learn more about that planetarium show at www.bigastronomy.org. And if you are a planetarium professional, you can even find out how you can show it for free or almost free in your dome. It also includes these live events in which we directly connect people with staff who work at these observatories and other STEM professionals, and educational toolkits created by the Astronomical Society of the Pacific, and educational research being done on the project by Michigan State University. So you will have an opportunity to help contribute to that research at the end of this program if you are interested. If you are joining us on our Zoom webinar, please make sure to select what language you would like to hear at the bottom of the Zoom window. If you're watching us on Facebook Live, Juan will be presenting in Spanish today, so the Facebook program will be in Spanish. If you'd like to hear it in English, just go ahead and click on the link of that Zoom webinar to join, and you'll be able to hear English interpretation. But with that, I'd like to turn the program over to Juan to tell us about the Cerro Tololo Inter-American Observatory telescopes. Thank you for being here, Juan.
Muchas gracias, René.
Thank you very much, Renee.
Bienvenidos y bienvenidas a todos.
Welcome, everyone.
Mi nombre es Juan Seguel.
My name is Juan Seguel. I'm
especialista en ciencia y
a specialist
educación
in
para el
science and
Observatorio
education
de Cerro,
for
NOIRLab.
NOIRLab in Aura, here at Cerro Tololo. And today, we're going to talk a little bit about one of our facilities, one of the oldest ones that we have here in the region of Coquimbo, and the Cerro Tololo Inter-American Observatory. So I'm going to share my screen now to present a few slides. There we go. So I'm going to start perhaps talking a little bit about the history of our observatory. Now, we're a new organization. Now it's called NOIRLab. We depend on the National Science Foundation, the NSF. In the case of Chile and other centers, it's run by AURA, the Association of Universities for Research in Astronomy. So to contextualize where we are geographically located, this is South America. Between these clouds, you can see there's a big space here that looks clear. And that's where most of the desert, Atacama Desert is. And we're located right here in the south of the Atacama Desert. So here there's a satellite picture that's looking at the northern part of Chile and Argentina. So this is the coast of Antofagasta, and here, this is where we run into the city of La Serena, and our observatory is approximately around here. So just so we can locate ourselves geographically, this is a facility we're talking about in Cerro Tololo. We're in the southern border of the Atacama Desert, one of the driest places on the planet, and it has some very specific characteristics. Not only is it highly arid, but there's also the presence of the Humboldt Current running along the coast of the country, and also the shape of the mountains, the Andes Mountains. It's very high in this area. It's above 5,500 meters above sea level. And this makes this place, or it gives it unique characteristics. So the people noticed this, or no, Chilean astronomers noticed this in the 1950s. So going back a little bit in history, just to contextualize why we set up an observatory that that depends on the or why did we actually set this up here in South America? Now, Dr. Federico Rutland was the director of the National Observatory in 1957. Dr. Rutland, he knew the particular traits that there's already an observatory that depended on the University of Chile here and before back then. And Dr. Rutland set up small telescopes on some hills around Santiago. Now, Dr. Rutland had an interview in 1958 with astronomers from the recently created Association of Universities for Research in Astronomy, AURA. And AURA was formed in 1957 due to the merger of several United or the joining of forces of several universities in the United States to improve astronomy in the country. And in that first interview, Dr. Rutland got together with Dr. Croupier, and they talked about the traits that Chile Skies had to, in the future, install an astronomical observatory, a world-class observatory that could also open the door to make it inter-American for astronomers from all around across Latin America and the world, so they could all perform research. So the AURA was building Kitt Peak, an observatory. It's a national observatory, and it's near Tucson, Arizona. And a few years after that, they decided to go to Chile, and they hired Dr. Jürgen Stock, who worked at Texas University, in order to, for over 3 years, study mountains in the north of the country, from the Santiago all the way up north. So Dr. Jürgen Stock, after 3 years of work, there you can see him along with his daughter. So finally, he reaches a conclusion that there's two candidates, so two important mountains, one much further north from where our facilities are now, but then also Cerro Tololo. That's where they made that decision on November 24th, 1962. In fact, right around Santiago, they made the decision. It was done through a commission, an AURA commission. And then that was the birth of the Cerro Tololo Observatory, due to the work, on one hand, of Dr. Rutland, and also thanks to Dr. Jürgen Stock, who was the first director of the observatory when it was being built. So they purchased a plot of land. They call it, so Totoral Hacienda. It's 35,000 hectares. These pictures from the 60s. This is 1962. So this is El Totoral. Here we can see part of a house. It's actually private property, 35,000 hectares, and it was purchased by AURA. So this is part of our historical archive. It's kept at AURA. And construction began in 1962. First, they had to build a road, and then up on the mountain, over almost 3 to 4 years, here's construction on top of the mountain, or Tololo Hill. It's 2,200 meters above sea level. So we have to chop off part of the summit in order to create the space to build the foundations of the telescope, their bases. In 1967, we officially inaugurated the Cerro Tololo Observatory on November 7th, 1967. It was inaugurated by the President of the Republic, and with the participation, obviously, of the entire board of AURA, including Dr. Croupier and other officials. from the organization. So now over 50 years have passed since that milestone, and Cerro Tololo today looks like this. The largest telescope on the summit is a Blanco telescope. It has 4 meters in diameter, and it was built after the inauguration of Cerro Tololo, and it entered operation in 1976. The other domes that we see here house a 1.5 diameter telescope, and here we have a 90 centimeter telescope, the Curtis Smith telescope. These are the original telescopes that were built between 1962 and 1967. Now, today, Cerro Tololo houses 35 telescopes at its summit. 35 telescopes, and many of which are robotic. So here, we're going to show you a picture of the northeastern side of our summit. And you can see lots of small domes. It looks like a big, it looks like a Smurf farm almost, right? And these robotic domes, these house telescopes from 80 centimeters in diameter up to, or smaller telescopes, 40 centimeters. And over here, we have telescopes that measure 1 meter, 1.3, and 1.6. Not all of these telescopes actually belong to our organization. Many of them belong to other bodies. For example, the one that we see here, this silver one on the right side of your screen, belongs to, it's Korean, it's called KASI, and it belongs to a network of telescopes to study, or for the Korean community. They have them all over the world, and one of them is set up right here in Chile. Over here, this telescope, T80, is a Brazilian telescope, and it's also set up on the summit of Cerro Tololo. So not only do we have telescopes that actually belong to our institution, we have telescopes that belong to universities and other countries around the world. 35 telescopes on the summit, and most of them are robotic, as I said. All of these telescopes, they don't have an actual operator, except for the larger ones, 1.3 and 1.6 over here. But all the other ones that you see, they're robotic, and we have several. More than 20 of our telescopes are completely robotic and operated remotely. Now, Aura, as we saw yesterday with Manuel Hernandez, is an organization that manages not just Cerro Tololo, and this is the project we're talking about, but as time has gone by, their work has become more complex because new projects and new participants have shown up in the world of astronomy. Aura also manages Gemini South in Chile, SOAR, a 4-meter telescope, and the future Vera C. Rubin telescope, an 8.4 diameter telescope that will really change the way that we see astronomy. It'll be the astronomy of future, and it's all about data. But let's go a little back to Cerro Tololo, and so I wanted to comment on, or what are the most important telescopes. And going back to the largest telescope, the Victor Blanco telescope, where we have set up one of the largest cameras in the world, the dark energy camera, or the DECam, and it has 520 megapixels. Now, this camera was set up in 2012, and it's been taking pictures over the last 7 years. And those astronomical images have really changed the way in which we see the universe. So just to cite an example of the DECam images, here's an icon of the Southern Hemisphere, which is 47 Tuc, which is a very iconic object. And you can see each one of these little blocks that you can see here. It's a detector. The dark energy cam has 62 detectors. So when we integrate the full image, this is what they look like. One complete DECam image weighs more than a gigabyte. That's just a single image. And when it's processed, it goes up to 4 or 5 gigabytes. But that's how heavy they are. So in this image here, that has a field of vision of approximately 4 full moons, we can capture objects. See that we see galaxies in this image, stars as well, and with a depth level and resolution that's extremely high, allowing us to find lots of celestial bodies and do lots of research. So just so you have an idea, this is what the BRC Rubin telescope is going to be like in the future. It's going to have a 3,200 megapixel camera, and it'll have even more depth and resolution to look into space. Now, surely you're asking yourselves, what are the milestones or the most important milestones of our Inter-American Observatory here at Cerro Tololo? Now, the most important milestones, they started from the very beginning of the observatory, but something very noteworthy happened about 9 years ago, because 9 years back, 3 people received the Nobel Prize in Physics, and they were astronomers. Perlmutter, Rice, and Schmidt. In 2011, they received a Nobel Prize for their work related to the search of supernovas and the measurement of the expansion of our universe. And their work, which was awarded in 2012, began back in 1997 by using the Victor Blanco telescope and other smaller telescopes as well that belong to our organization. And that ultimately led them to see supernovas, stars that have the trait that they explode. And they needed many of these in order to prove their theory. And their theory was that the universe, or the speed of deceleration, or what speed, or if the expansion of the universe was slowing down, but they were finding that no, it was actually the expansion was speeding up, and there was something that was pushing galaxies to separate from each other. And this led them to get the Nobel Prize and also changed the paradigm in modern astronomy. Up to 1997, we thought that we knew that we had seen 95% of the universe, but today we know that we only know about 5% of our universe. And that 5% is made up of heavy elements, like the ones we see on our planet, also neutrinos, stars, and the hydrogen that's, or free hydrogen in space, and nebulae, and in the halos around galaxies, etc. There's a 25% of the universe that's made up of what we call dark matter, which are within galaxies, but we still don't really know what it is, and also something that's called dark energy, which is between galaxies, and it makes galaxies stray away from each other at an accelerating rate, and which is what was discovered by these 3 researchers. That's precisely what they discovered, this acceleration of the universe, and that was happening for something that until today we still don't really know. Thanks to their discovery, we built DECam, the dark energy cam, because it really tried to understand that this 95% of the universe that is still unknown to us. The DECam data is analyzed until today, and we still don't really have an answer to dark matter and dark energy. And the fact that we call it dark, it's not just because we can't see it, it's also because it represents the level of uncertainty that we really have on the subject. So there's still lots of work to be done in astronomy. We only really know 5% of our universe, and we're unaware of the other 95. So that's the really most important milestone of our telescope, Victor Blanco telescope, having participated or actively participated in this research. However, there's other interesting discoveries as well, and perhaps if traveling from our solar system, I can show you some of them. For example, in 2018, using DECam and the Victor Blanco telescope, we discovered 12 new moons of Jupiter. And these 12 new moons are located in the furthest part of of the group of moons, the farthest out group of moons. Now, these are very small moons. Actually, this one that we say here, that's called Valetudo, is one of the smallest ones because it measures approximately 1 kilometer in diameter. And the Dark Energy Cam discovered them by coincidence. And, and after 2 years of research, they determined that there was actually 12 new moons. So now we know that Jupiter has a total of 79 known moons. And 12 of them are discovered thanks to the Dark Energy Cam from the Cerro Tololo Inter-American Observatory, specifically the Victor Blanco telescope. And this telescope also discovered one of the farthest objects in our solar system. 2015 TG387, they call it the Goblin, is an object that's found very, very far away in our solar system. This also changes the way in which we understood our solar system. We used to think that we weren't going to run into objects beyond certain regions in the outer solar system, but we found more than one actually. We already knew Sedna for many years, and then we discovered 2012 VP113, and in 2018, I'm sorry, in 2015, we discovered this object that they nicknamed the Goblin. This was published in 2018, and they were all discovered using the dark energy camera in projects that together with, or not just using the Cerro Tololo Observatory, but along with other institutions like Carnegie in Washington, because these projects are always the joint efforts with astronomers from different institutions. So these are some of the main milestones, just to point them out. And if we go even further beyond our solar system and to the nearest stars, we can see a project called Recon that's starting in I believe 1999. We're looking for stars close to our sun, and this project starting in 1999 until today by using the 0.9 meter diameter telescope on Cerro Tololo, we found 44 stars close to our sun at a distance of approximately between or up to 33 to 40 light years away. But it's another interesting milestone. Many of these star systems are new to us, and 44 new stars, they're very faint. That's why we need relatively large telescopes to find them, but also lots of patience in order to measure these objects, because sometimes we don't notice them in giant telescopes. But this 0.9 meter telescope, along with the work of devoted scientists, added 44 new stars to our catalog, and all of them close to our suns. So that's just some data regarding some of the main milestones discovered here at Cerro Tololo. And obviously, behind all of this, there has to be people from different specialties, different backgrounds that make this observatory actually work. This is a picture of the last total solar eclipse in 2019, and we can see part of our staff. They're posing after the eclipse together with a 4-meter telescope. And many of them are not astronomers, they're technicians, they're engineers, they're maintenance staff, people who don't necessarily have astronomy as something that they studied in college, or it's not their research specialty. They're people that in their own expertise as technicians or engineers or maintenance personnel, or even secretaries, personnel or human resources, accountants. Their expertise really brings life to this huge observatory that allows us to do all this research. Behind all this research, that there's a diverse human team. People are very devoted and committed to science research and to make their contribution, sometimes from an area that many times it isn't directly related to science, but their contribution ultimately allows scientists and astronomers who research here, it allows that allows them to do their jobs and hopefully open up the universe to new research in the future. And with that, I'd like to thank everyone. And now we can open the floor up to questions so we can talk about all these things. So thank you very much.
Thank you, Juan. It's great. 30, did you say 36 telescopes on the mountain? That's amazing. We do have a question from a Facebook viewer, Nelson, who's watching from Calama, Chile. He wants to know what was the name of the other hill where the observatory was potentially going to be built?
Era una montaña
It was
cerca
a
de
mountain that was
cerca de Copiapó.
near Copiapó
Em,
city.
Sí, y si no me- si mal no
If I
recuerdo,
remember correctly, I believe it was called,
creo que se llamaba Campanario.
I think it was called Campanario Hill, I believe.
Era una montaña
That was the name.
en
It was a
altura
mountain.
similar,
It was very similar in height to Tololo Hill,
pero estaba al sur de la
but
ciudad
it
de
was
Copiapó, la
south
provincia
of the city of Copiapó, which is almost 250 to 300 kilometers further up north in La Serena.
I loved seeing those pictures from the 60s when the site was being built. It was really interesting to see that history. I have a question. Knowing that the Vera Rubin Observatory is going to be using a big camera in the secondary mirror, similar to the Blanco telescope and the dark energy camera, was the dark energy camera an inspiration for the new Rubin Observatory?
no necesariamente.
Not necessarily. The Dark Energy Cam project is advancing at the same rate as the VRC Rubin camera. Both, I believe, or we have to understand that even though the VRC Rubin project is being built right now, its origins go back to the year 2000, 20 years ago. The Dark Energy Cam project is a few years after that. And even though in its original role it was VRC Rubin had considered a camera with a large field of view. We actually didn't know what its final characteristics were going to be. So they were kind of working at the same time in parallel. So it doesn't mean that one really depended on the other. They were heading on parallel lanes, and the dark energy camera was developed first because its objective was precisely to understand a little bit more about things that we were unaware of, like dark energy and dark matter. And Vera Rubin was on a parallel route, advancing towards hopefully giving us new knowledge regarding the entire universe, this whole new world that's related to data and the phenomena that change very quickly. So that's why Vera Rubin telescope is going to really scan the night sky over 4 or 5 nights, because we really want to see these changes that we sometimes miss in astronomy.
Thank you. There's another question from a Facebook viewer. How many astronomers are working at Sololo right now? Which countries are they from?
Aproximadamente.
Well, approximately at Cerro Tololo, if I'm not mistaken, I believe that there's 15 astronomers are on staff, 15, 16 astronomers, and they come from different nationalities. We have astronomers that are from Holland, from the Netherlands. We have Chileans from the United States, New Zealanders, Russian as well. So there's a whole multiverse of astronomers. They're men and women working in astronomy. It's not just men. It's also female astronomers. They're working in this area. But I'd say it's 15 to 16.
Another question from a Facebook viewer, Bruno. Do you consider potential space pollution that could be increased by satellites sent by SpaceX or other commercial companies like Amazon or Facebook a threat to the astronomy being done on Tololo?
Bueno, todos estos
Well,
proyectos
all of these projects,
de satélites,
the satellite or the low altitude satellite projects are definitely a problem for the development of astronomy from on the ground observation, not just for us, but also for other projects such as the VRC Ruben, for a GMT, or
para todos estos proyectos
for all of
gigantes
these giant telescope projects.
van a ser un problema porque
They will be an issue because these telescopes are much more sensitive
son
and
mucho
their
más
fields of vision are much larger. For example, we DECam has a 2.2 degree field of vision, like 4 full moons. But even though we can screen or remove or try to avoid to point in certain directions, knowing when these satellites will cross by, we know that the amount of satellites is pretty considerable, which will become a problem. And for that reason, the scientific community has started to open conversations in order to deal with this problem and avoid the future impact of this type of technology that's currently happening and how it'll affect astronomy with ground observations with telescopes such as ours.
Lenore wants to know what is the most relevant research that has been done on Cerro Tololo, in your opinion?
Bueno, creo que
Well, I think that
algo que abordé en mi charla
I touched on it in my presentation, and I think that that's the work that was done
Víctor Blanco, 4
in
metros,
Victor Blanco, the 4-meter telescope, and its
el
participation in the study of supernovas and how this led us
de descubrir la
to discover the acceleration of the universe and directly related to the Nobel Prize awarded in 2011, Nobel Prize in Physics given to 3 astronomers. Obviously, I'm not saying that the work aren't important, but I believe this is the most important one. Because in all of these telescopes, important work is being done. But I believe this is one of the most important ones because it really shifted the way that we look at this universe and how to understand the universe.
Pretty amazing that the astronomers set out to discover one thing and the data told them exactly the opposite, right?
Yes.
Another question from Nelson, a Facebook viewer. Is there a date for the end of operations in the observatory? And he says that he hopes not.
Aunque todos los observatorios se
Even though
crean
all observatories are created with with a period of time in mind, or be it 20 years or 25 years, 30 years of observations, eventually the institution is always really in extending these deadlines. Obviously, all projects are created with a period in mind, but our facilities, for example, have continued to work for more than over 57 years to date, 58 once we reach mid-November. So yes, hopefully we'll be able to turn 100 or more and always doing astronomy research. But that will depend on the funds from the National Science Foundation because they're very important for the operation of our observatory. Our observatory depends 100% of that financing in order to continue operation and to be open because we're a laboratory of astronomy that's open to the entire scientific community, not just from the United States, but also the entire world community to do astronomy research and top-notch research.
I think one last question from Miriam, and she asks, "What is it like to be an astronomer? Is it difficult, and do you see it as impossible?"
Bueno, yo no soy astrónomo.
Actually, I'm not an astronomer, but I can still answer the question because all career has its degree of difficulty, starting from your first studies until you get your PhD. and
se requiere
you
dedicación,
require
dedicación,
time,
trabajo, oración.
dedication in order to achieve it. But
Siempre que a uno le guste lo que
if you really like or
ese,
enjoy what you're
ese
doing,
trabajo,
that
puede
job or
eh,
that the
va a tener
effort that you put
finalmente
in
un
will
fruto,
ultimately
un
reach
beneficio
good
final.
results. You'll feel
Eh,
satisfied.
y el trabajo de un astrónomo o una
And the
astrónoma no
work
es
of an
más difícil
astronomer
que un
isn't harder
científico
than the work of an
o un
engineer
especialista en cualquier área.
or a
Simplemente
specialist in any other area.
requiere,
It just
uno trabaja
requires,
de cierta manera en
obviously,
lugares muy especiales, como el
but
caso
you work in
de
very
estar
special
aquí,
places, like as you can see behind me in that picture.
pero uno lo hace porque le gusta.
But we
Muchos
do
de
it because we like it,
todos nuestros
and
colegas trabajan
all of our
porque
colleagues work
les
there
gusta
because
lo
they
que hacen.
love what we
Y
do.
creo que eso hace que
And I think
sea
that
fácil
makes it
todos los trabajos
not be so hard.
tienen su
Obviously,
grado de
all jobs
complejidad,
have a level of
pero
complexity,
si
but
uno está satisfecho y contento haciendo
if you're
algo
really
que
fulfilled
apasiona,
and happy with what you're
esa
doing,
dificultad pasa a un
that
segundo plano y
difficulty
se siente
is almost
como
forgotten, and you just
haciendo
continue
algo
blazing on. And in this case, doing our research
y
work
tu desarrollo profesional.
and developing as a professional.
So a follow-up question to that one: you're not an astronomer; you're an astronomy educator, an outreach professional. What was your path? How did you come to work for the observatory in this capacity?
Bueno, mi área de formación, yo soy un
Well,
ingeniero.
I'm a trained engineer, a civil mechanical engineer,
Que siempre he estado
and I've
trabajando
always
con
been
astronomía
related with astronomy or working around
durante la
astronomy
universidad, primero
since
como
I was back in
aficionado,
college. First, just as an
como
aficionado,
estudiante universitario,
when I was a
luego
college student, we actually created
una maestría en la
a,
Universidad de
a,
Concepción
an astronomy club in the University of
y
Concepcion,
ese último
about
tiempo,
1,000 kilometers south of La Serena.
ese trabajo,
And that work,
esa pasión de cierta
or
manera
that
por la
passion
astronomía me llevó
for astronomy, really led me
poder
to
ser primero un ayudante
first be able
para un
to be an
investigador
assistant for an
recién
astronomer
llegado a la universidad.
who had just arrived to the
Luego de
university.
eso,
And after that,
comencé a trabajar en
I
astronomía
started working
profesional
in astronomy more in a professional
con
capacity,
él durante
doing
casi
research
25
together with
años
him over almost 5 years.
después me trajo acá al
And
observatorio
then
de Cerro
he
Tololo
brought me over here to Cerro Tololo
como
Observatory first as an
científico de
engineer.
ensayos, o sea,
We
site
were
engineer,
a site testing
y
engineer.
después
And then
en los últimos casi
over the
10
past
años,
almost
diría yo,
10 years, 9 to 10 years,
especialista
as a
en
specialist
educación
in education.
y que justamente
And
todo este camino me ha
because
llevado
this
a
entire
poder
path has really led me to
reconocer
understand
como
not
aficionado
only or not just as a fan of astronomy, I can recognize objects that I see at night, but also
cómo funcionan
it's helped me as an engineer how telescopes actually work,
cómo se construyen, cómo
how
se
they're
diseñan,
constructed,
cómo se
how
trabaja de
they're
noche,
aligned,
que estamos
how we
seguros
work at night in order to keep them
y
running, and
detrás de
also
la
from a
investigación.
point of view of research,
Trabajé haciendo
I,
investigación,
I, I
apoyando
got to work
proyectos y siempre
researching
sentí
and
buscando
doing
siempre
research,
esa
supporting research, and so I know what astronomers really do. So having all of these little pieces of the puzzle,
un poquito de ingeniería, un poquito
a
de
little bit of
ciencia,
engineering, a little bit of
también
astronomy,
educación,
and a bit of education,
muchas actividades de extensión,
because I did lots of
me
outreach
llevaron a
activities
donde
when I was
estoy
in college.
y
That's what
poder
led me to where I am today, to
en
be able
distintas oportunidades aportar
to see these with these different views. I can make a contribution with my expertise
a la educación
and
y la
contribute to
extensión
education and
en el
outreach
observatorio.
here at the observatory.
Well, thank you so much. Thank you for your time today, Juan. Thank you, Sebastian, for your interpretation for those of you who are listening to the English interpretation. And thank you to our viewers for tuning in to learn more about the many telescopes on Cerro Tololo and some of the exciting science that is being done there. If you'd like to continue learning about this big astronomy topic and about all the many diverse careers it takes to make this big observatories happen, all the people that contribute to science at these observatories, I hope you'll follow us on social media. You can follow us on Facebook, Instagram, and Twitter so that you can learn about more upcoming events. Our next event is on November 11th, and this event is called Real People, Big Astronomy, and it will feature Dr. Luis Chaviara, who will be speaking about his path. He is the head of astronomy, the astronomy program for the Ministry of Science in Chile. So we're excited about that. We'll be just talking about how he got involved in astronomy. And you can also visit www.bigastronomy.org to get onto our mailing list if you'd like to get an email about upcoming events. Finally, this program is a part of the National Science Foundation funded program that has educational research associated with it. So we have some opportunities for you to contribute to the research if you are interested. There'll be some links put here in the webinar and on Facebook Live. If you would like to fill out a survey, you can be entered into a drawing for a $10 Amazon gift card. And there'll also be a link for a Zoom focus group. And if you join that focus group, you will receive a $5 Amazon gift card. So you can find those links. I'll be posting them into the webinar shortly, and you'll see them in the Facebook Live comments as well. So we hope that you'll consider supporting the project by doing one of those two things if you are interested. So thanks so much, Juan, for coming today. I really enjoyed the program, and I know our viewers did too. We'll see you again soon.
Muchas gracias, René. Nos vemos. Muchas gracias. Saludos.
Thank you very much, Renee.